So anytime we're dealing with right angle triangles, we need to understand a certain amount of terminology associated with these. And we need to understand a certain amount of processes to calculate some of these lines. First off, if I was to discuss or to talk about this triangle and I want to know, well, if I'm going to say that the angle that I'm going to discuss is right here, this X, I would call this line right here the side adjacent. This would be the side adjacent to this angle. This line right here would be the side opposite. And it is the side opposite of this angle here. And now these two can be interchangeable depending if I'm talking about this angle or this angle. This line in a right angle triangle is called the hypotenuse. So we use this terminology often, and I will use it quite a bit as we go through trigonometry, this intake. But we also, in our trade, talk about right angle triangles, and we call sometimes this line the run. We call this line the rise, or we call it the offset or the set. And we call this line the travel. Right? So the hypotenuse and the travel. The side opposite is the rise or the offset or the set, and the side adjacent is the run, if I'm talking about this angle right there. So when I'm talking about a right angle triangle, ooh, yeah, there we go. And it is a 45-degree right angle triangle. The right angle right here indicates 90 degrees. The 45, if it's a 45-degree right angle, this angle has to also be 45 degrees because every triangle, right angle triangle, comes up to 180 degrees total. So in a 45-degree right angle triangle, the run and the rise are the same. The rise and run are always the same in a 45-degree right angle triangle, because clearly what it is that it is a box or a perfect square cut in half, right? And so all of the sides are equal. That's exactly how I know that this is equal to that and that is equal to that. It's a perfect square cut in half, and that gives me this right there. Is that clear? Is there anything anybody want to add, or you want to ask a question at this point? Is everybody okay with this? All right. We're going to continue on. So I'm going to move this up. So I want to tell you that in a 45-degree right-angled triangle, the travel is always 1.414 times longer than the run or the rise. In a 45-degree right-angled triangle, the travel is always 1.414 times longer. And we can prove this using Pythagorean theorem. Pythagorean theorem says that a squared plus b squared is equal to c squared. Now, I told you that the rise and the run are always the same on a 45-degree right-angled triangle. So if I said this was 1 and this was 1, then we could calculate the travel or the hypotenuse using Pythagorean theorem. And so that would be 1 squared plus 1 squared is equal to c squared. As you know, 1 squared is equal to 1. So that is equal to c squared. So 2 is equal to c squared. I want to get c all by itself. To do that, I square root c squared, square root 2. C is going to equal 1.414. And that's where we get that number from. So let's do some examples with this. Let me just go here. No, here. I don't know where this is. I thought I had it. Nope, 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 nope. I had this sitting in my drop-down menu here, and now I don't know what I did with it. There we go. So using that information we just, here, let me put it over here. Using that information we just got, we're going to do a couple of these questions. So we could just use a decimal of an inch. That is quite fine by me. So if my set or offset is 10 inches, then what is my run? Just shout it out. 10. The rise or the offset and the run are always the same. These two are always equal. And now my travel on this formula is 10 times 1.414 times longer. The travel has to be 14.14.
Is this in a book somewhere?
No, it's not.
Okay.
I just have this.
This is from first year.
It is from first year. That is correct. But I got to bring you all the way back. So let's go to B. So if my run is 1 foot 4 inches, my set or offset has to be 1 foot 4 inches, or 16 inches. Yes, has to be. They are the same. Thank you, Josh. Now, what is my travel? What is this travel right here?
22.624.
Yeah, it's going to be 16 times 1.414. Yes, so that's going to be 22.624 or 5/8, as Kyle wanted to tell us. And that is correct, inches. How about this one? Look at C right here. We have 2.5 feet is equal to the travel. How would I find the run or the set according to this?
Slide.
That's right. We will divide by 1.414. So we can go 2.5, which is equal to 2 feet 6 inches. 2.5 feet divided by 1.414. And that comes out to 1.76 feet. Is everybody with me? I'm not worried about breaking it down to inches and fractions of an inch right now. This is not my biggest concern. What I want to do is just get you into the feeling of this number. The 1.414 is exactly what I'm trying to do. So let's go to D. So that says 3 foot 5 inches. I'm going to take 5, divide it by 12 to get it into a decimal of a feet or of a foot. And that equals 0.4166 is enough. So that's 3.4166 feet. So I could write that in there because the offset and the run are the same. And this is 1.414 times longer. So my travel in this should be 4.831 feet. Is everybody with me with this? Pretty easy stuff, yeah? Is it okay? Everybody's okay with this? Excellent. I'm going to insert another sheet here. And that's not the one I want again. There it is. I think. One more example before I go. Before I go on to the other one. That's what I just did. Why isn't a fitting allowance in here? Okay, it's somewhere else. Hang on. I got a lot of files. I got way too many. There we are. Okay, so this one here, this is also a review of last year. But I want to tell you first off that these 3 rows right here, the throw minus the engagement is equal to the fitting allowance. Okay. Yeah, that's right, Brad. So 3, then if the throw minus the engagement is the fitting allowance, then the fitting allowance for this is 1 inch. Okay, does everybody see that? Fitting allowance is 1 inch per fitting. Now, A is right here. A is 22 inches on this example. B over here is 10 inches on this example. This right here is the travel. Now, what I'm going to do is I'm going to draw a right angle triangle. Just like that. There's my right angle. Now, the run in this one, the run is right here. Can anybody tell me what the run is? What measurement the run is?
12.
That's
12
right.
inches.
We take 22 and we minus 10. So this is 12. So if this is 12, then what is my travel?
16.968.
So what we did is took 12 inches and multiplied it by 1.414 to get my travel of 16.968. That is a center to center measurement. So what would be my end to end measurement?
18.968.
How many fittings do we have?
2.
We have 2 fittings. So we have to take 2 fittings off of the 16 to get 14.968. Okay. So let's do the second one here. Oh, I froze. So the second one says B is 35, or A is 35, B is 18. And if I draw a right angle triangle in here, it's not perfect, but there it is. What would my run be? Pretty straightforward. 17, right? 35 minus 18 is 17 inches. Now we could calculate the travel times it by 1.414, and that equals 24.038. Here's my throw, here's my engagement, so my fitting allowance is a 1/2 inch. And my end-to-end measurement here is going to be 2 fittings off of this, so that's going to be 23.038 is my end-to-end measurement, or my cut length. So that would be my cut length. Let's move on to C. So I'm just doing a bunch of examples with you here. So if this is 490 and this is 250 mils, what is my run? 490 minus 250. My run is going to be 240 millimeters. And now my travel would equal 339.36 millimeters. Look at my throw here is 25. My engagement is 15. So my fitting allowance is 10 mils. I have to take 20 mils off of this. So this is going to be 319.36 millimeters. So now I'm going to go down here to the bottom and I'm going to say, look at this. My end-to-end measurement is 12. So my fitting allowance is 4 minus 3 is 1 inch. So that tells me my center to center travel has to be 14 inches, right? 2 fittings to center. And now to get my run, I will take 14 and divide it by 1.414. And that's going to equal 9.9 inches is my run. And as you can see up here, you take your run and add it to your B to get A. So this is going to be 29.9 inches. And that's just how to do it backwards. Cool.
Sorry, how did you get 14 again?
I added 2 fittings to it because my fitting allowance is 1 inch. My end to end is 12. So I have 2 fittings to get my center to center. That's how I got the 14. Awesome. That's not the one I want. Okay. This, well, let me just push this over a little bit and down. Okay, let me just scroll in here. This is your parallel offset project. Now, it says here that is for 3rd year plumber. No more of that. This is for 2nd year plumber. Okay. Now, in your instructions for your parallel pipe offset, we will continue after the break. And I will, there we go. I'll try not to make any more bad jokes or talk about my wife like that. That's not very nice. I mean, she's a very kind person. She's so kind, almost to a fault. That her husband is starving. And I'm all, you know, just saying. Okay, so in this sheet, this is your instructions. I'm number 4. No, you'd see number 4 in there. There's number 4. Just kidding. Anyways, we will work in pairs when we're doing this. Okay, we got to make sure all center to center calculations are based upon the sheet, and that's what we're going to do a little bit today. When you have your threading machine, you're going to have to replace the threaders, clean, set up. Okay, cut required lengths, properly ream pipe, assemble project, clean project, pressure test, deliver for marking. That's to me. disassemble, return all fittings, cut off threads, clean and return clean shop. So that's the instructions that we're going to have you do. So you will get a marking sheet, or what sometimes is called a rubric. That's kind of a fancy term for a marking sheet, okay? Just gives us parameters of what those marks are going to be within. So we are going to basic installation. Okay, sketch and dimensions, that's your picture. Most everybody will get a 10 on that. So pipe A and pipe B have to be within these measurements to get these marks, okay? So the farther you are away from these correct measurements, you will lose some marks. Similarly, with pipe C and pipe D, the closer you are to the exact measurement, the better your marks, okay? We are going to look at thread length. We're going to look and make sure your pipe is reamed. We're going to check your squareness of your project. We're going to do an air test, and you got to make sure that you are safe at all times. Yeah. All right. There's going to be no hours missed, so I don't think that's going to be an issue. And having said that, here is the project that you are to build. Okay. So if you have a printable or printed version of this, you can write down your answers on this as well. So what we want to do is we have to determine our pipe A, our pipe B, our pipe C, and our pipe D. These are the measurements that are not given on this picture. So we will determine these measurements. First off, we're going to do pipe C, as you can see right here. Now, all of these measurements are going to be, going to be in center to center measurements. All right, all of them that we do here today is center to center. As you can see, they are also in center to center measurements. Now, I want to highlight some of these measurements right now. This is 9 inches, and this is 3/4 inch pipe. So that is the size of the pipe you will use. This is 6 inches. This is 8 inches in here, 4 inches center to center in here, and that is center between the T and the 90, center to center. Center to center down at the bottom, the whole project. Center to center is 2 feet. Yes, center. That's center of the 90 to center of the 90, 2 feet. Here is 1 inch pipe. So this is a different piece of pipe. 1 inch pipe in here, 1 inch pipe here, 3/4 pipe here. Now, you will have to make these nipples. You will use the nipple chuck in the vise and you will make these nipples. I don't care how long each one of them is. You just have to get this measurement correct, right? We will determine what this overall measurement is in a bit. Okay, so you have to pay attention to the pipe and the lengths that we are already given. First off, we're going to calculate C. Now, I have a measurement here to there. Can everybody see that measurement that I have from there to there? That 15 inches. Everybody see that? 15 inches. So if I have 24 inches overall at the bottom, I can determine that C equals 9 inches center to center. Right? Has to equal 24. Something in the chat and I can't see it. I don't know why. There it is. Okay. Thank you, Tesfaye. Yeah, 9. So we got C. C is 9 inches. And C is going to be in 3/4 inch pipe. Yes. C is also going to be in 3/4 inch pipe. The next measurement we are going to get is B. Let's look at B. So we can see B is over here on the far right side. We have this measurement to this point is 6 inches. And then from here down, we have 4 inches. What is pipe B? 10 inches. Yeah. Center to center. But B is going to be 1 inch pipe. So you can see it's right there, 1 inch pipe for B. Excellent. Now we want to calculate D. And to do that, I got to do a little bit of trigonometry, quite frankly. So I am going to draw a right angle triangle right in here. See my right angle triangle there? What I did is I split the 45s in half, making my right angle triangle 22.5 degrees. So that's 45 divided by 2, right? I cut the 45 in half. So this angle right here on this triangle is 22.5 degrees. Does everybody agree with that statement? Okay, so hold on to that thought for a second. I'm going to move this over. I'm going to draw that 22.5 degree right angle triangle right here. Oh, that didn't work out. Let me go back. There we go. That's better. So this is 22.5 degree angle right here. Okay. So that's this angle over on the picture there. So I want to tell you that anytime we have a 22.5 degree angle, or for that matter, any right angle triangle with it, an angle there, you will take the run, and that's this measurement. The run is this line, and you're going to multiply it by the angle, and we're going to do the tangent of that angle, and that would equal the rise. So that would equal that line. For example, if you take the run, and this was a 45 degree, you're going to multiply that by 45 tan. So in your calculator, I want you to hit the 45 button and hit the tan button. Does it say 1? Yeah, and that equals the rise. So that tells me the run and the rise are always equal, right? But in a 22.5 degree right angle triangle, you're going to take the run and you're going to multiply it by 22.510. That's the tangent. And then that would equal the rise. And this number should be 0.414. So in your calculator, do 22.5 and press the tan button. Should be 0.414, yes? Right. Brett, I just noticed your message in the chat there. Yes, this is in an ILM and it's called trigonometry. Or more specifically, it's called stainless steel miters is where this stuff is. And this is trigonometry, and this is a very shortened version because we just need this formula right here to solve for this. So now I'm going to go back to my picture. And as you can see, I'm going to highlight this in a different color. Do you see the run? Oh, let me just get a different color. Do you see the run right here? You see that run? How long is this run right here? Everybody see that run?
8.
It's 8 inches. And if I multiplied that by the 22.510, 0.414, I can get this measurement right here. That would give me the rise of this triangle. So 8 times 0.414 is equal to, anybody?
3.312.
Thank you. Inches. So this line right here, this run is equal to 3.312 inches. So now I can get the measurement D by adding 9 inches to that, right? You see where the 9 inches come in? So D is equal to 12.312. And that is a center to center measurement. And this is also 1 inch pipe. Does everybody see that there? Everybody's got that? Okay, now,
Oh my.
you all right, Brett? Now, I'm going to take that information and first off, let's have a look. Well, I'm going to pick or cherry pick a number here. So we have this 9 inch pipe. Let's look at this one right here. This 9 inch pipe has a 45 right here, and it has a T right here. So we want to get the end to end measurement of that particular pipe. Okay, we have the center to center. Let's get the end to end. So if you have an IPT Pipe Trades Handbook at approximately page 181, I don't know if it's in 181, but this picture right here shows us our malleable iron fittings. Is it 181? Close to it? Yeah. Okay. So you can see if we have a 90 or a T or a 45. So the fitting allowance for a 90 is A minus the thread T is equal to my fitting allowance. For a 45-degree elbow, it's going to be, so for a 45, the fitting allowance is equal to the letter B minus T. Everybody see that? So that's how we do fitting allowance. So we take these letters, and these letters are located on the next page. Well, this page is for millimeters. We are working with inches, and I said 3/4 inch, and we're looking for the fitting allowance of a 45 and of a T. So I said, this is 3/4 inch. You're gonna go right here at 3/4. And A is for the T. So we're gonna go 1.31, and we're gonna minus off the thread engagement. So we're gonna minus off 0.5. So we have to take off 0.81 inches off of the T to get the end measurement. Now I need a 45. I need the fitting allowance for that 45. And it said take B and minus T. So the 45 is 0.98 minus 0.5, which is equal to 0.48 of an inch. So that's for the 45. So I'll add these two together. And the fitting allowance for those two fitting is 1.29 inches. So I'll go back to my project. I have it here somewhere.
For, because we're in the table for malleable iron fittings, are we going to be using that for our project too, or are we going to be using the steel dimensions?
It's the malleable iron fittings. Those are the steel fittings. That's exactly
okay.
what we're going to be using. So
Okay.
my center to center is 9 inches, center to center, and I must minus off 1.29 inches off of that to get me my end to end measurement. Oh God, why does that do that to me? And so that would be 9 minus 1.29. So pipe, this pipe right here should be at 7.71 inches. So you're going to make that pipe 7.71 inches right there. And that's how we calculate end to end measurements. What diagram are we looking at? The shop diagram, Brad? Is that?
Yes, sir.
Okay, I emailed that to you today.
So Doug,
And I put it in the chat as well.
for finding the end to end there, do you always minus off that 0.5 or whatever the thread engagement would be?
That is correct.
Okay.
Yeah, so
For
you
all
take
fittings.
whatever the fitting is. So I'll go back to that table. Whatever the fitting is, ooh, where are we here? Oh, it's up here. Whatever fitting it is, you will find out what this letter is, and then you minus off your thread length. Okay. And that's how you do that.
I think there's a digital copy of this in the App Store.
What, the IPT book?
Yeah, I think you had to pay for it, but I'm pretty sure it's there.
Okay, hang on a second. Do you guys want me to send you a digital copy of the IPT book?
Will we need to have the book in shop class?
I would suggest you bring your IPT book to shop class.
I'm just thinking for in the field, you usually have your phone on you, so it'd be easier to find it on your phone than having a book on you at all times.
Well, that's true, but some job sites, Matt, don't allow you to have a phone. So what I'll do is I will email you guys that. Hang on a second, let me stop sharing here. I'm going to email you guys the IPT book, just so you have it, all right? Is that okay if you have it? Is that all right? Yeah, okay.
Thank you, sir.
Let's see, email. Upload. Oh. Oh, it was mama. Oh, gosh. Oh, I can't send it. It's too big. They won't let me. They won't let me send it. The file's too big. Dang. Dang it, dang it, dang it. Okay, so
Do you have Dropbox or anything like that?
I do.
There's actually an app called MRC Global. It's a pipe fitter's handbook. It's the same thing.
That's
Use-
right. Actually, that's pretty good, Jarrett. The pipe fitter's handbook is pretty decent, I must say. So you should have the IPT book anyways, so bring it to school. You have that project now, so you can work on that and get all of your cut length measurements before you come to shop class. So we could just go over safety and give you a little demonstration and then kind of cut you loose and get you working on your project quicker. Yeah? Does that make sense? Justin, I will not change the measurements when we get to shop. This is the exact project we're going to do. All right. So thanks for that. I mean, that would be, well, that'd be kind of diabolical, wouldn't it? It'd be a good idea. Thanks for that. Thanks for the good idea, Justin. Appreciate you. Really do.
Here's the measurement for A there.
A. You want it, what? I'm not doing a measurement for A. You can.
Okay.
Now, you have, quite frankly, a lot of homework, people. Right? Let me outline this again. Tyler, you're bringing in your own pipe? Good for you. You have the assignment for temperature and heat, right? That's new one I just released today. Secondly, you have the shop project you can continue to work on to get all of your end-to-end cut measurements. Thirdly, you have the rigging to modules on rigging that I outlined for you this morning.